Hi, we will find the recurrence equation for the quickshot algorithm. The quickshot algorithm is explained in detail in the previous video. So now we will only see how to calculate the recurrence relation for the quickshot. Quickshot is following the dividing approach. Then here we are partitioning the given list into half of the elements until reaching the initial condition. Then recursively we will call the function to sort out the element. Finally we will merge the we will combine all the sublisted partitions. So here n is divided into n by 2. Then here the n by 2 will be less than or equal. Here also n by 2 less than or equal, because for after every recursive call the pivot element will be positioned in the right index, okay, correct index of the array. So after placing this pivot element, we will not consider for the next recursive calls. Only we will take pivot index minus 1, pivot index minus 1. Okay, here pivot index minus 1 only we will take this number of elements for one partition. Here also we will take pivot index plus 1, pivot index plus 1 to last element. So this is also less than or equal to half of the elements. This is also less than or equal to n by 2 elements. So that's why we are saying here or less than or equal to n by 2. Here pivot element will be selected as selected from first element of the array or last element of the array. So from this, here for quicksort we will partition the element by calling this function. This function is having some n number of statements. It will be partitioned into reaching the single element in the given array. So it will take some constant number of times of this time for this executing function, right? Now after partitioning we will take each subpart. Okay, each subpart will be considered for short out, right? For that, that subpart will take t of n by 2 time, and right partition will take t of n by 2 time. For example, this will take t of n by 2 time. This partition also will take t n by 2 time. Then when you are dividing this, it will take t of n by 4 time. This will take t of n by 4 time. So it will keep on go until t of 1. So based upon that, we are simply saying 2 times of n by 2 for considering the two partitions of the subarray. Now based upon that, here if condition also will check some constant amount of time. Okay, so here we can say this one by adding t of n by 2 plus t of n by 2 plus c times of n plus c. So this is the recurrence relation for the quick shot. So based upon that, now we will solve the recurrence relation to find out the complexity of the quick shot. So here whenever your array is having single element, then it will consume only constant amount of time. If there is more than one element in our arrays, for example if you are having 3 5 here 0, then it will take 2 times of n by 2 plus constant amount of n time n plus c. So now we are taking this equation, and condition is here n is greater than 1. Now breaking this problem with size n greater than 1 into sub problems by replacing the n with n by 2 in this equation. So wherever n is available, you have to substitute with the entire term. So entire term when you are substituting, you will get t of n by 2 equal to 2, this one is 2 times of n by 2 by 2 plus c into n by 2 plus c. So this is the entire term. So now you got this one, so you have to substitute into this equation. Okay, in this equation, so when you are substituting that equation, you will get, right? So in this equation or simplified equation, in this simplified equation, so in this simplified equation when you are substituting, you will get the this two already existing, so we are substituting here, then this entire term. So 2t of n by 4, 4, we will take this n by 4 plus c times of n by 2 plus this c is this one, okay, this one. Then again here we are having the cn, that is this one, and this c is this one, okay. So now we have substituted all the values. When you are simplifying this, you will get 4 times of n by 4 plus 2cn. So here this will cancel, then you will get this term cn, so 2cn plus 2c. Now again we are breaking this n by 2 into n by 4. When you are substituting that, you will get this term like this, okay. So 8 times of n by 8 plus 3cn plus 3c. Now here you observe the pattern. Here we are having the 3, so we can get 8 by substituting the 2 power 3. So here also we can substitute the 2 power 3. So when you are substituting that, you will get the time complexity 2 power 3 times of 2 n by 2 power 3 plus 3n into c plus 3c. So when you are repeating this k times, because you keep on do this until getting the single element in the subarray, so you assume this is the k times. So when you are repeating this for k times, here you will substitute the k, because this is the third time. Like that, k times 2 power k t of n by 2 power k here, then this is k times of cn, this is also k times of constant. Then what is the initial condition here? Initial condition is here 1. Initial condition is here 1. So until reaching the initial condition, we have to keep on do that. When you will get the initial condition here, so initial condition you can get whenever you are substituting n equal to 2 power k. So when you are substituting the n equal to 2 power k, so t of 2 power k divided by 2 power k, in this place when you are substituting, you will get the t of 1. So now what is the value here? N equal to 2 power k. So in the place of n, you substitute the 2 power k, right? When you are applying the logarithm for both places, both sides, right side and left side, you will get log n equal to log 2 to log base 2 2 power k. Then you will get the k times of log 2 power 2. This term will become 1. Then now k equal to log n, okay, k equal to log n. Now replace this in the place of here, okay, in the place of this equation. So now when you are substituting this t of 1 is n power 2k, okay, you will get the t of 1 here. Then here you will get log n in the place of k. In the place of k, you are substituting the log n, then into cn, then plus c is this one, then k equal to log n, k equal to log n. So now here in this place n 2 power k, here we are having 2 power k is here n, this value. Actually here 2 power k should be there, okay. Here 2 power k should be there. In this place 2 power k should be there. So 2 power k is now n. Then t of 1 log n into cn plus c times of log n. So now when you are comparing the t of 1, it will be the 1 unit of time, this one 1 unit of time. So now n into 1, n into log n. So we are omitting the constant value n into log n. Then here also we are omitting the c value log n, because constant coefficient will be ignored whenever you are having the higher order term here, okay. So now we are omitting the constants. The finally we are checking lower order term. So these are all lower order term. N is lower order one lower order term, so we are ignoring this. And here log n is lower order term when you are comparing with the n times of log n, okay. So we are ignoring this. So finally you are getting n times of log n for the quick sort. This is the time complexity of quick sort algorithm. Thanks for watching.